correct. In this video, I'm going to cover system design interview questions. Basically, in this part, I'm going to cover the fundamental question. In the second part and the third part of the video, I will cover the medium level and advanced level question. So without wasting time, let's get started. So in this video, I will cover these questions, whatever mentioned in the screen, starting with the first question. So what is system design? System design is a foundation of building a scalable, reliable, and maintainable software system. So it is not just about writing code, it's about architecturing how different parts of the system interact, how data flow, and how performance is maintained under load. So whether you are designing a social media app, a payment gateway, or a cloud service system, design help you to think out the big picture. So what happens when a millions of users hit your app at once? This is a very big question. So how do you store and retrieve data efficiently? How do you ensure your system the data doesn't crash when one part of the system fails? So in the interview, system design questions test your ability to break down complex problems, make trade-off, and communicate clearly. In real-world engineering, it's what separates good developer from great architect. So over the next 60 questions, so we'll explore everything from basics concept like scalability, caching to advanced topic like distributed system and real world case studies. Whether you are beginning or preparing for the following interview, this will basically going to help you in every perspective. High level and low level system design. So system design is often split into two layers. First one is high level design and second one is low level design. So high level design focuses on architecture. It answers questions like what are the main components, how do they interact, what technologies we are going to use, things of it as a blueprint, defining modules, data flow, and system boundaries. Low level designs dive into details. It includes class diagram, database schema, API contract, and internal logic. This is where you decide how each component works internally. So imagine building a house. High level design is a floor plan, while LLD is the wiring, plumbing, and material. Both are essential. Skipping one leads to fragile system. So one tip from my side, always start with HLD to see the context, then drill down to the LLD when needed. This shows structure, thinking, and clarity. Moving to the third question, client-server architecture in system design. Client-server architecture is the backbone of most of the application. It is simple yet powerful model where client like browser or application send request and server responds with data and action. Client, this is a user facing part. It could be a web browser, mobile app, desktop software. It handles UI and send request to the server. Server, the backend, it process requests, interact with database and return responses. It is where the business logic lives. This separation allows scalability, modularity, and better security. For example, your Instagram app is the client, and the Instagram server handles your feed like messages, likes, and share. Interview, you might be asked to design system design like design WhatsApp. Know how client and server interact in system design. Bonus, add layers like load balancer, caching, database to make it robust. We will cover those soon as well. Moving to the fourth question, monolithic versus microservices architecture. So choosing between monolithic and microservice architecture is one of the first big decision in system design. Monolithic in monolithic architecture, everything is built as a single unit, one code base, one deployment. It is simple to start with, but can become hard to scale and maintain the system grow. So microservice architecture is like the system is broken into independent services, each handling a specific function like user service, payment service. They communicate via API and can be deployed separately. So pros and cons of monolithic and microservices. Pros of monolithic. Easier to develop and test initially. Simple deployment. Cons. Hard to scale part independently. Tight coupling leads to fragile system. Pros and cons of the microservice architecture. Scalability and flexibility. Team can work independently in their module. Cons are complex communication and deployment. Require strong DevOps for and monitoring. Moving to the next question. If you are new to this channel, please consider like, share and subscribe to my channel. This will help me to get motivated. Moving ahead to the next question. What is scalability? In vertical scaling and horizontal scaling in system design. Scalability means your system can handle increased load without breaking. It is one of the most important goals in system design. So vertical scaling means add more power to your existing server. So add more power means CPU and RAM. It's simple. It is simple but has limit. You cannot scale infinitely, right? So horizontal scaling, add more servers to handle the load. In horizontal scaling, we add more server to handle the load. This is more complex but allows near infinite scaling. Thinks of adding more lanes to a highway versus making one lane wider. Real world example like Instagram scale horizontally by adding more server to handle billions of requests. Challenges with horizontal scaling, data consistency, load balancing, and distributed system. Moving to next question. What is load balancer? Imagine thousands of users hitting your app at once. Without a traffic cop, one server could get overwhelmed while others sit idle. That's where the load balancing is coming. Load balancer basically distribute incoming requests across multiple servers to ensure no single server bears the full load. This improves performance, availability, and fault tolerance. If one server goes down, the load balancer redirects traffic to a healthy one, keeping your system alive and responsive. There are different strategies. First one is round robin, distribute requests evenly. Least connection, send traffic to the server with fewest active connection. IP hashing, route based on your IP for session consistency. In interview, mentioning load balancer so you understand its scalability and reliability. In real world scenario, it is non-negotiable. So this is very important point. And in the real world problem, you will see load balancer in day-to-day life. Moving to the next question. Moving to the next question, caching. What is caching? Caching is one of the most powerful tools in system design. It stores frequently accessed data in memory, so future requests are saved for faster. So it reduces latency and load on your database. So imagine a user opens your app and see their profiles. Instead of querying the database every time, you cache the profile data. Next time it loads instantly. So type of caching, client side, server side, and distributed caching. Client side caching means browser store data. Server side caching means backend caches response or data. Distributed caching means tool like Redis or Memcache store data across nodes. Where to cache? Database queries, API response, and static assets like images, CSS, and JS. But caching is not magic. You need to handle. So you need to handle different things like cache invalidation, eviction policies, and consistency. Moving to the next question. What is SQL versus non-SQL? Choosing the right database in system is very crucial. So database are the heart of any system. Choosing between SQL and NoSQL depends on your data structure, scalability needs, and query pattern. SQL, also known as relational database, use structured table with predefined schema, great for complex queries, join, and transactional integrity. Example, MySQL and PostgreSQL. Non-SQL means non-relational database, flexible schema, ideal for unstructured or semi-structured data, scales horizontally, and handle massive volumes. Type includes document-based MongoDB, key-value Redis, graph Neo4j. Use SQL database when you need ACID compliance. Relationship between data are important. You perform complex joins and aggregation. You should use NoSQL when you need high scalability. Data structure is dynamic. You prioritize speed over strict consistency. Moving to the next question, what is cap theorem? In distributed system, you cannot have it all. The cap theorem states that a system can only guarantee two of the following tries: consistency, availability, and partition tolerance. Consistency means every read get the latest way right. Availability means every request get a response. Partition tolerance means the system continues to operate despite network failure. So you must choose your trade-off. CP system prioritize consistency and partition tolerance. AP system in Cassandra prioritize availability and partition tolerance. Moving to the next question, what is latency and throughput in system design? Performance is not just about speed. It is about how your system handles loads, right? Two key metrics, latency and throughput, are very important. Latency means time taken to respond to a request. Lower latency is equal to faster response. Throughput means number of requests handled per second. Higher throughput, better capacity. Imagine a request restaurant. Latency, how fast one customer gets served. And throughput, how many customers are served in an hour. Optimizing latency improve user experience. Optimizing throughput improve scalability. How to reduce latency? Use caching mechanism. Optimize database queries. Minimize network hops. How to increase throughput? Use load balancing. Scale horizontally. And use asynchronous processing. Stateless versus stateful services. One of the most important decisions in the system design is whether your service should be stateless or stateful. This choice affects scalability, reliability, and complexity. Stateless service does not retain any information about previous request. Each request is independent, and the server does not need to remember anything. This makes it easy to scale horizontally. You can add more server without worrying about session data. REST API are typically stateless. Stateful service basically maintain context between requests. For example, a user login session or a multi-layer game server need to remember who you are and what you are doing. These services are harder to scale because you need to manage session persistence, often using sticky session or external storage like Redis. Why do this matter? Stateless servers are easier to load balance, cache, and recover from failure. But some use cases demand stateful behavior like chat app, video calls, or personalized dashboard. Moving to the next question. What is REST, GraphQL, and gRPC? As you know, API are the bridges between services and client. Choosing the right API style like REST, GraphQL, or gRPC can make or break your system performance and developer experience as well. What is REST? REST, known as representational state transfer, the most common API style. It uses HTTP method, get, put, post, delete, and exposes resource via URLs. Simple, stateless, and widely supported. GraphQL, query language for API. Clients specify exactly what data they need, reducing overfetching and underfetching, ideal for mobile app and complex UIs, requires a schema and resolver logic. gRPC means Google Remote Procedure Call, a high-performance binary protocol using HTTP by 2, great for internal microservice communication, support streaming, and is language agnostic. When to use what? Use REST for public API and simple CRUD operation. Use GraphQL when client need flexibility and control over data. Use gRPC for low latency, high throughput, internal service. Moving to the next question, what is API gateway? The front door of your system, you can say. API gateway is single entry point for all client requests. It acts as a reverse proxy, routing requests to appropriate service, handling authentication, rate limiting, logging, and more. Think of it as a receptionist of your system. It knows where to send each request and ensure only authorized user to get through. Benefit of using API gateway, centralized routing, simplifies client logic, Authentication and authorization, validation tokens and user roles. Rate limiting, prevent abuse and protect backend services. Monitoring and logging, track uses and errors. Caching, improve performance for repeated requests. Popular tools include Kong, AWS API Gateway, NGINX. In microservice architecture, API gateway is essential. Without it, client would need to know the address of every services. Moving to the next question, CDN, Content Delivery Network. Content Delivery Network is a network of servers distributed globally that deliver content to the user from nearest location. It is a game changer for performance and scalability. When a user requests to a static asset like image, video, CSS file, the CDN serves it from the closest edge server, reducing latency and load on your origin server. Benefit of using a CDN: faster load time, content is delivered from nearby server, reduce server load, offload traffic from your main infrastructure, improve availability. If one server fails, other take over. Security. CDN offer DDoS protection and HTTP support. Popular CDN include Cloudflare, Akamai, Amazon CloudFront, and Fastly. Use CDNs for assets like images, CSS, video streaming, software downloads, and API caching. Moving to the next question, rate limiting. Very important topic. Rate limiting is a technique to control how many requests a user or client can make in a given interval of time. It protects your system from abuse, spam, and accidental overload. Imagine someone sends 1000, 10,000 requests per minute to your login API. Without rate limiting, your server could crash, right? With rate limiting, you block or delay excessive requests. Common strategies like fixed window, sliding window, token bucket, leaky bucket. Where to apply rate limiting? Login and sign up endpoints, payment API, public API, and expensive database queries. Yeah, that's all in today's session. Hope you liked the session. If so, please like, share, and subscribe to my channel. And I will share the next part, second and third part of this video very soon. Thank you.